Hi, and welcome to this video on solving word problems for an unknown. Before we get started, I'd like to remind you that you can pause the video at any time, jot down, take any notes, and even back up, rewind it to go over things that you might not have understood it the first time. And of course, if you have any additional questions, jot them down, and then contact an instructor here at Penn Foster, either through telephone or email, and we'll be more than happy to answer your questions for you. Okay? All right. Solving word problems for an unknown. I have several slides here, and this first slide is kind of like the steps that you would go through, the process that you would go through for solving word problems. All right. Students do have a difficult time because I think it's not that they can't do the math, it's that they don't know how to put together a process, and they also have a difficult time translating the English into mathematical operators. But hopefully by the end of this video you'll have a little bit better idea, and all it would take is just practice in order to master it. Okay, so let's start here with step number one. You need to understand the situation, right? That means you carefully read the problem and read it several times, and so that you can wrap your head around what the problem is all about. Step number two, you need to identify all of the parts of the situation. These can be just about anything as variables, like money, cars, pizza pies. A variable can be just about anything. Right? Separate them into what you know and you don't know, and then also ask yourself what the problem is looking for. This is important. You have to know what you're trying to solve. A lot of students will read the problem and have no clue what they're looking for, what they're trying to figure out, and they just start in and they're just totally lost because they have no direction. Right? Step three, what math relationships exist between the knowns and the unknowns, what you know and what you don't know. Use a chart of keywords, and the next slide will be the equation. Right? Let a variable represent the unknown. Right? So if you don't know something, you assign it a variable, and the variable could be just about any letter. All right? It doesn't matter what it is. It could be the letter A, X, V, T. It's a variable. There is no concrete constant number that you're assigning to it. So you just pick a letter and you say that's what my unknown is. Okay? And if the problem has more than one unknown, you want to represent the second unknown in the terms of the same variable as the first unknown. For example, if the problem has two unknowns, we would assign y as one of the unknowns, and the second unknown might be 4y. Now, this would be 4 times the first unknown, 4 times y. Okay. Step 4, we create an equation. You visualize the relationship between unknowns and variables. Then set up an equation to solve for the unknowns. When you're solving, you put what you know on one side of the equal side and what you don't know on the other side of the equal sign. Right? And then solve for the unknown. Okay, step 5, you check your result to see if it's accurate. Does the answer make sense? You plug your solution back into the equation to see if both sides equal, to see if it's correct. If it isn't, either the equation is set up incorrectly, or maybe you did something wrong, like you did the math wrong. But if this happens, you kind of have to go back and start again. All right? So let's move on to the next slide. Okay. Again, you can pause the video at any time and jot these down. Okay. Keywords and phrases for creating equations. Right. When you're reading the problem, you're going to be reading in English, and like I said, a lot of students have difficulty translating the English into mathematical operators. So this is just a list of words that kind of denote the mathematical operator. For example, equals obviously is equal, but total is the sum of would be addition. All right, it wouldn't be multiplication, and it wouldn't be division because you're totaling, right? You're adding them up. Subtraction, smaller than, well, that's, or less than, that's taking away, subtraction. The product of, multiplication, 2 times 3, well, it gives you a product, 6. Division, divided by, or like the average of, when you're taking an average, you're going to divide by how many, pieces of information that you have there. Right? And this last one is parentheses, times the quantity of. I'm just going to take a quick second here and explain this. If it's above you, like if you already know this, great, but sometimes I think students have difficulty explaining what they're talking about in mathematical terms. They say one thing and it makes no sense because they're not using the language of math. Let's say we have an equation, let's say d plus 1. Okay. Now, if I wanted to multiply this equation by 2, the way I would write it is, and I would say it is 2 times the quantity. The quantity is this parentheses, d plus 1. Okay? So whenever I'm reading something like this, I'll say 2 times the quantity, d plus 1. This parentheses actually means you're going to multiply 2 times whatever's inside the parentheses. So 2 times d would be 2d, and 2 times 1 would be 2. Okay, and that's how you'd multiply it out. But the parentheses is times the quantity, and notice it's times. That's multiplication. Okay, all right, so let's move on. And I have a problem here. All right, a word problem, and we'll kind of work this out on the next slide. But let's read over the problem because we want to read it a few times so that we understand, the various parts of the problem and what it's looking for. Okay, the St. Louis Post-Dispatch on October 25, 2006 reported on ticket scalpers. Cardinals World Series tickets were selling at 15 times more than the highest ticket face value. Others were about 8 times the lowest face value. Pete Morgan paid $400 for the lowest ticket at face value, and Dennis Spivey paid 9 3/8 times the amount paid by Pete. How much did Dennis pay for his ticket? Okay. One of the things that I think about when I'm doing a problem is I want to know what is directly related to solving the problem. I want to know what has nothing to do with solving the problem. And I also want to know what it is that I have to change in some way in order to help me solve the problem. All right. So I'm going to move on to the next slide. And this is where I'll work the problem out. And what I'm going to do is, if you listen to me, this is my thought process as I go through solving this problem. Now, my way is not the only way, and it's not the best way. It's just one way, and it's a way that works for me. Okay. So here I go. I already read the problem once, so I have some idea as to what's involved, but I'm going to read it again and start thinking about different things. The St. Louis Post-Dispatch on October 25, 2006 reported on ticket scalpers. Well, there's really nothing in that sentence that is important for this particular problem, so that's kind of like useless information. It's stuff I could throw out other than I know it's talking about ticket scalpers. Cardinals World Series tickets were selling at 15 times more than the highest ticket face value. Right? Well, I don't care if they're Cardinals, World Series, Bears, Yankees, Mets, whatever, right? World Series tickets. What's important to me is that it's 15 times more than the highest ticket face value. Now, I don't know if I'm going to use that information, but it's just something to store in the back of my head. All right. Okay. We'll continue on. Others were about 8 times the lowest face value. Okay. So here we have 15 times the highest and 8 times the lowest. Now, I don't know what I'm going to do with that. but they're two pieces of information, right? I don't know if I'm going to use them or whatever have you. What I know is that I don't know what the highest ticket face value is. That's an unknown. And I don't know what the lowest face value is. That's also an unknown. I mean, I do know I'm selling it 15 times more and 15 times less, right? If I wanted to look at it, I could say, okay, let's call it the highest. We'll make it H. We're going to set it as a variable. And we don't know what H is. But we know that 15 times, right, whatever the highest value is, would be, how much is being paid. So if the highest price was 100, right, well, 15 times 100 is equal to 1,500. But the highest price could have been just as easily been 200, right? Which would make, that's times, which would make that 3,000. Again, I don't know. All I know is that it's 15 times the highest price. I could plug in numbers and play, but in order to be able to verify information. But it's until we actually work through an equation, I don't know. And the same thing with the lowest, right? Well, the lowest is 8 times. Right? Well, the lowest, could have been $10, right? Which would make it 80. Lowest could have been $20, which would make it 160. I don't know. Okay? So, let's erase all of that. It's just thoughts that are going through my mind here, okay? As I work through a problem. You gather your information and you use it as needed, right? It doesn't mean you have to use it. That's why I said directly related to solving a problem, has nothing to do with a problem, and has to be manipulated or changed in order to help with the problem. Right? So, we'll continue on. Pete Morgan paid $400 for the lowest ticket at face value. Okay? Well, if the lowest, he's paying $400 for the lowest ticket, we don't know what that lowest ticket amount is, but we know Pete is paying $400 for it. Right? Dennis Spivey paid 9 3/8 times the amount paid by Pete. Okay, well, if Pete is paying $400 for that lowest price ticket, right? We don't know what that lowest price ticket is, right? We don't know how much that, it's 8 times that. But we do know that Pete paid $400 for it. Dennis Spivey is paying 9 3/8 times what Pete paid. And the question is asking me, how much did Dennis pay for his ticket? Well, if we want to know what Dennis's ticket is, we don't know what it is right now, so let's assign it a variable, and we'll call it a T. Right? T for ticket. And we know that Pete paid $400. Okay? Well, Dennis Spivey paid 9 3/8 times the amount paid by Pete. So Pete pays $400. Dennis is paying 9 3/8 times that amount. Okay, so this, when I look back on my problem, this 15 times the highest ticket value, it just, I don't need that information. 8 times the lowest face value, I don't need that information. All that is important right now for this problem, since we want to know how much Dennis paid for his ticket, is that Pete paid $400 and Dennis is paying 9 3/8 times that. Well, T for Dennis is equal to the 400 times 9 3/8. I just created my equation, right, based upon the information that I know. So now I have my unknowns on one side and I have my knowns on the other side. I know $400. I know 9 3/8 times on the other side. So now all I need to do is just solve the problem. So solve the equation. So that's 900 times 8 times 9 is 72 plus 3 is 75 over 8. And when I multiply across the numerators, I get 30,000, right? Okay, I wrote a K here. I could have just as easy, the K represents thousands, meaning 000 is equal to K. Okay, this is just an accounting thing that I happen to always do. What I actually have written here is 30,000, right? In shortcut form is 30K. It saves me from writing all those extra zeros. That's just a little thing that I happen to always do from accounting. All right. So I have 30,000 over 1 times 8 is 8. All right. So Dennis is paying 3,000. When I divide, Dennis is paying $3,750 for the ticket. Okay. And that's the solution to the problem. Now again, you can go back over this video and rewatch it again, listen to it several different times, listen to my thought process. Notice how I worked through the problem. I was trying to decide, what is useful, what isn't useful, what's the relationships there, what could possibly be the variables, and I created myself an equation. Then I solved for the equation. I came out with an answer. All right. So again, watch the video several times, and following along with that, it's the same process. Use that first slide with the steps. Use the second slide with the keywords, and practice. Doing these, it's more about practice. Each problem is going to have a little something different. But once you've done enough, enough problems, you're going to notice that it's called pattern recognition. You're going to notice the pattern that you see in word problems, and you'll be able to attack them the same, each one the same way all the time, so that you can solve for that particular problem. It's a lot of work up front. You're not going to know, you're going to struggle, you're just going to get stuck sometimes. And when you do, you can call and speak with an instructor or contact us via email, and we'll be more than happy to help you out with that. Okay, so again, watch it several times, and if you have any additional questions, give us a holler. All right, thanks, and have a great day.